So, hello everybody. I am Professor Swamreddy from SR University. In lecture 1, we already discussed the introduction of Laplace transform and sufficient conditions for the existence of Laplace transform and some standard functions of Laplace transform. In this lecture 2, we are going to discuss the fast shifting theorem. So, what is fast shifting theorem? Here, the Laplace transform of f of t, the Laplace transform of f of t is f bar of s. Is it right? F bar of s. Then the Laplace transform e to the power of at into f of t, product of your two functions with exponential function e power at into f of t is f bar of s minus a. Means just simply s is replaced by s minus a. Right? If it is e to the power of at, right? If the Laplace transform of e to the power of minus at into f of t, what we write? S is replaced by s plus a. S is replaced by s plus a. Here, s is replaced by s minus a, e to the power of at. Here, e to the power of minus at, s is replaced by s plus a. Right? First, you find the Laplace transform of f of t. Then in that f of t replace s by s minus a if it is e power at. If it is e power minus at, s is replaced by s plus a. This is the first shifting theorem. For example, if you see the Laplace transform of t power n. What is the Laplace transform of t power n? N factorial by s power n plus 1. Right? The Laplace transform of any function is denoted by f bar of s. Right? Now, what is the Laplace transform e power at into t power n? By using first shifting theorem, s is replaced by s minus a. So n factorial, right? Here the Laplace transform e power at into t power n is n factorial by in place of s, s minus a, right? Whole to the power of n plus 1. Just in place of s, s minus a. This is the Laplace transform e power at into t power n, right? And similarly, if you see the Laplace transform, right, e power at into sine bt. You know the Laplace transform of sine bt. What is sine bt Laplace transform? B by s square plus b square, right? Now, by first shifting theorem, what you say? The Laplace transform e power at into sine bt is just replace in this b by s square plus b square raised by s minus a. So b by s minus a whole square plus b square. This is the Laplace transform of e power at into sine bt. Similarly, what do we write? Suppose e to the power of minus at into sine bt is there. Sine bt is there. So then what do you write here? This is equal to, right, b by s plus a. S is replaced by s plus a plus b square. S is replaced by s plus a whole square plus b square. Right? Just the change is here. E power at, if e power at s minus, if e power minus at s plus a. This is the first shifting theorem. And next is e power at into cos bt. So what is the Laplace transform of cos bt? The Laplace transform of cos bt. What is that? S by, right, s square plus b square cos bt. Now by first shifting theorem, by first shifting theorem, right, the Laplace transform of e power at into cos bt. Just to replace s by s minus a. So s minus a by s minus a whole square plus b square. This is by first shifting theorem, right? And next is find the Laplace transform of t sin at and t cos at. So what is our first shifting theorem? Only the first shifting theorem gives only the product is e power at into f of t, right? So in this case, what do you say? F bar is s is replaced by s minus a, and e power minus at into f of t. This is equal f bar of s plus a. S is replaced by s plus a. Right? But what about this t sin at and t cos at using first shifting theorem? How you calculate this? So, but our first shifting theorem gives only the product of e power at into f of t or e power minus at into f of t. But here t into sin at, t into cos at. So, in this case, just you write here t into e power iat, the Laplace transform t into e to the power of iat, e to the power of iat, right? So e to the power of iat, then we apply first first shifting theorem, right? So here, what is the Laplace transform of t? 1 by s square. Now t into e power iat, f bar is s minus a, e to the power of is a positive e to the power of iat. So s is replaced by here, s is replaced by s minus ia. So s is replaced by s minus a, right? So then rationalize this. S plus ia whole square, s plus ia whole square, divide and multiply and divide. So by simplification, what we get here? E power iat, right? S square, right? 2ab, 2asi minus a square. This s square plus a square whole square. How it is? Just you a plus a square minus b square is a plus b into a minus b, right? So here t cos a t. Then what is e power iat here? The Laplace transform t into e to the power of iat. What do we write here? Here t into, right? The Laplace transform of this. Laplace transform t into e power I theta. What is e to the power of I theta? E to the power of I theta is equal cos theta plus I sin theta. Then you write down. So t into, right, cos t or cos at e power I at cos at plus I sin at. Just expand e power a. Now just compare real parts. This is real part and this is imaginary part. Both sides comparing the real and imaginary part. So what is the real part here? Left hand side t cos at. Here what is the real part and right hand side? S square minus a square by s square plus a square whole square, right? So s square minus a square, s square plus a square whole square. This is a real part. So this is a Laplace transform t cos at, t into cos at, and imaginary part compare. So right left side imaginary part is t sin at. The right side imaginary part is 2as by s square plus a square. So by first shifting theorem we can write both of the Laplace transform t sin at into t cos at. Is it right? And next is uh, find the Laplace transform of e to the power of 4t sin 2t cos 2, just cos t. You know the formula sin a into cos b, sin a into cos b, sin of a plus b plus sin of a minus b. So a plus b, 2, 2t plus t is sin 3t plus sin of a minus b, 2t minus t is sin t. I should apply. What is the 2 sin A cos B? Formula is, what is that? Sin A plus B plus sin of A minus B, this one. So here multiply and divide with 2 here. This is 1 by 2. That's why you write 1 by 2. So A is 2t and B is a t. So 2t plus t is 3t, A plus B. And 2t minus t is, right? 2t minus t is sin t. So now apply Laplace transform of sin 3t, 3 by s square plus 3 square, cos t, 1 by s square plus 1 square. Now by first shifting theorem, e to the power of 4t sin 2t cos t is 1 by 2 into, just in this replace here, replace s by s minus 4. So s minus 4 whole square, because e power 40 here in the s minus 4, right, in both the, right, sin 2t and sin t, right. This is about first shifting theorem application. Next, hyperbolic function. Here the Laplace transform of e power at into sin hbt. You know sin hbt Laplace transform, b by s square minus b square. E power at, just you replace s by s minus a, s by s minus a. So b by s minus a whole square minus b square, right? And e power minus 8 is sin hbt. Similarly, s is replaced by s plus a, right? S is replaced by s plus a. Here, e to the power of minus 8 is sin hbt. In this case, s is replaced by s plus a, because e to the power of minus 80. Here, plus 80. Is it right? This is a first theorem application. Next, the Laplace transform e power at cos bt. Laplace transform e power at cos hbt. What is the Laplace transform cos hbt? The Laplace transform cos hbt equal to s by s square minus b square. This is s by s square minus b square. Now e power at, the Laplace transform of e to the power of at cos hbt. Cos hbt is s is replaced by s minus a. So s minus a by, right, s minus a whole square minus b square. Just similarly, this s plus a, s is replaced by here e power minus 80 cos hbt. S is replaced by s plus a. In this case, s is replaced by s plus a. This is the applications of first shifting theorem. Next, now let's take this here. The Laplace transform e to the power of minus 3t. Is it right? Uh, Sine square t. Sine square t. You write down sine square t is equal to, what is sine square theta? You know sine square theta equal to 1 minus cos 2 theta by 2. So in place of theta, t simply. So 1 minus cos 2 theta by 2. Now separately apply Laplace transform. Laplace transform 1 by 2 and Laplace transform cos 2t. What is the Laplace transform? Any constant, constant by s. So constant by s. And Laplace transform cos 2t is, right, s by Laplace transform cos 8. What is the Laplace transform cos 8? Cos 8 is s by s square plus a square. Right? Similarly, a is equal to, so s by s square plus 2 square. The Laplace transform cos 2t. Right? Now e to the power of minus 3t sin square t we need. Is it now s is replaced by, here in this fraction, s is replaced by s plus 3. S is replaced by s plus 3. So e to the power of minus 3 sin square is s is replaced by s plus 3. Right? S is replaced by s plus 3. S is replaced by s plus 3. Right? So this is a Laplace transform e to the power of minus 3t and sine square t. Next, the Laplace transform of e to the power of minus 3t and t cube. First you calculate the Laplace transform of t cube. The Laplace transform t cube is, what is the t cube? 3 factorial by the Laplace transform t cube is 3 factorial by 3 plus 1. So 3 factorial and a 6 by s plus 4. Now e to the power of minus 3t t cube. By first P theorem, s is replaced by s plus 3. So 3 factorial is 6, right? S plus 3 whole to the power of 4, right? You know the Laplace transform of t power n. From that you put n is equal to 3. T power n is n factorial by s power n plus 1 is general formula. Just you put n is equal, just you put n is equal to 1, 2, 3 like that. You get t power 1, t power 2, right? Now change of scale property. So what is change of scale property? The Laplace transform, you know the Laplace transform f of t is f bar of s. It right. Now the Laplace transform f of in place of t a t f of a t change here, scale is change. T is replaced by a t here, right? A t. So that is 1 by a into f bar of s by a, right? Because here in place of t a t, so 1 by a into f bar of s by a. This is the change of scale property. Now apply change of scale property. Find cos phi t Laplace transform. You know already the Laplace transform cos bt, right? Sin bt. By applying change of scale property also we can calculate. If you forgot this, then you apply change of scale property. So what is the Laplace transform of cos t? S by s square plus 1 square f bar of s, right? S by s square plus. Now here the Laplace transform of cos phi t in place of t cos phi t. So that is by change of scale property 1 by phi into f bar of s by phi. So in place of s what do you write? S by phi. So 1 by phi s by phi. Here s by phi whole square plus 1. Now take LCM s by s square plus 25 Laplace transform cos phi t. Right? And next is, now by applying change of scale property, find the Laplace transform of, right, sin h3t. So sin, you know sin ht Laplace transform. What is the sin ht Laplace transform? 1 by, right, 1 by s square minus 1 square sin ht Laplace transform. Right. Now by change of scale property, sin h3t is 1 by 3 f bar of s by 3. Sin h8 is 1 by a f bar of s by a, like a is equal to 3 here. So this is by change of scale property. Now let's write here 1 by 3. In place of s what we write? In place of s by 3 whole square minus 1. Now the LCM is here s square 3 square, just you take LCM, and this is the after simplification 3 by s square minus 3 square. This is the Laplace transform sin H3T. Problems on change of scale property. Find the Laplace transform of sin at by t given that the Laplace transform of sin t by t is tan inverse 1 by s. Right? First you take uh, f of t. Here f of t equal to sin t by t. Just to assume sin t by t. By using change of scale property, what is the formula? Laplace transform of f of a t, not t, a into t. That is a change of scale. So that is 1 by a into f bar of s by a. Right? Actually, the Laplace transform f of t is f bar of s. But here f of a t, a into t. Right? Now, the Laplace transform of, let's take sin at by at in place of sin at by at, right? This is equal to, what do you say, 1 by a is a 1 by a tan inverse 1 by s by a in place of s by a, right? Now let's common here, a common, this is 1 by a Laplace transform sin at by t, denominator a common. This is equal to 1 by a tan inverse, it is sent to numerator a by s, a by s, right? Now here this is uh, 1 by a and this is 1 by a gets cancelled. So the Laplace transform of sin at by t is equal to simply tan inverse a by s. If you put a is equal to 1, you will get this one. You will get this one. Right? This is about change of scale property. Right? And next is, now the Laplace transform of derivatives. So what is the Laplace transform of derivatives? Here f of t be a function, right? F of t by a function. Their Laplace transform f of t is equal, f bar of s, f bar of s, right? Now the Laplace transform derivatives. How? First, f dash t must be continuous. Then the Laplace transform f of t is f bar of s. This is a condition. Now the Laplace transform first order derivative is Laplace transform f dash of t, f dash of t is equal to s into Laplace transform f of t minus f of 0, right? Or this is equal to Laplace transform f dash t is equal to s into, what is the Laplace transform f of t? F bar of s, right? F bar of s, this is f bar of s minus f of 0. This is the Laplace transform f dash of t, right? F dash of t. Similarly, f double dash also. F double dash of t is equal to s into f dash of t minus f dash of 0. Then the Laplace transform of f double dash t, f double dash t equal to s into, right, Laplace transform f dash t. Here the Laplace transform of f dash t is s into Laplace transform f of t. One derivative, here no derivative. Here two derivatives, one derivative, right? Just easy to remember. Minus f dash of 0, f dash of 0. Now let's substitute here the Laplace transform f dash t, you know this equation. Just Laplace transform is f dash t is s into f bar of s minus f of 0. Substitute here, right? So that is the Laplace transform of f double dash of t is equal to, right? We are just to substitute here s into, what is this, s into f dash t Laplace transform is s into, right, Laplace transform. Yes, we substitute here s into s. You can write s square also, direct also, or you write this here, right? S into f bar of s minus f of 0 minus f dash of 0. Yes, I am substituting. So here let's s into s square f bar of s, right, minus s into f of 0 minus f dash of 0. Right? So this is about first order derivative Laplace transform and second order derivative Laplace transform. Similarly, we can write third order also. Just you see, similarly, you can write third order also. Here, f triple dash of t is equal to s cube f bar of s minus s square f of 0 minus s into f dash of 0 minus s into f double dash of 0. Third order derivative, right? And next, fourth order derivative. You should observe here, third order derivative start with s cube. Now s power decreases s cube, s square, s, here s power 0. That's why 1. Now f bar of s, right? This is s square and f of 0, f, f, f dash of 0, f double dash of 0. Right? This f bar of s is Laplace transform f of t. Here f of 0, f dash of 0, f double dash of 0. If it is triple dash, you would get double dash. Similarly, fourth, you would get triple dash. Start with here s power 4 f bar of s minus s cube f of 0 s square f dash of 0 s power decreases s power 1 f double dash of 0 s power 0 f triple dash. Similarly, we can write nth derivative also. Nth order derivative f power n f of t is equal to s power n f bar of s minus s power n minus 1 f of 0 minus s power n minus 2 f dash of 0 minus s power n minus 3 f double dash of 0 and so on. N minus 1 as in. Just you see nth derivative end with n minus 1 here. Say fourth derivative end with triple derivative. Third derivative end with second derivative. Here s power decreases s power n, n minus 1, n minus 2, n minus 3 and so on, n minus 1. Like that decreases. Is it right? Now we are s power 4, s cube, s square, s power 1, right? S power 0. Start with order derivative power also here. Right? This is about Laplace transform derivatives formula. Using this, we can solve some problems also on derivatives. Using the Laplace transform derivatives, calculate, right? Laplace transform of t, Laplace transform of t. First, f of t is equal to, you assume t, f dash t is derivative of t is 1. F dash of 0 is also 1, t is equal to 0. F dash of 0 is 1, t is equal to 1, this is 1. F of 0 is 0. Why f of 0 0? Here f of t is equal to t. Just you put t is equal to 0. F of 0 is 0. F dash of t is 1. Derivative of t is 1. Here f dash of 0 is 1. First order derivative Laplace transform f dash of t equal to s into Laplace transform f of t. S into Laplace transform f of t minus f of 0. Here f dash of t, what is f dash of t value? 1. Just substitute. F of t, what is f of t? T, Laplace transform of t. Whatever you write in the above line, just you substitute in the formula. Yes, f of t is t, right? F dash t is 1. Here f of 0 is 0. Therefore, just you take the Laplace transform of t equal to 1. Laplace transform any constant is constant by s, right? So now s send this side. So Laplace transform t, right? Laplace transform t is 1 by s square. Similarly, you can calculate this Laplace transform e power at also. Just you write the first order derivative formula and substitute. First order derivative formula and substitute. Second order derivative formula. Next, for next questions, you can take this is second order derivative formula. Sin 80 is a second order derivative formula. Just apply, right? And this is also second order derivative t into sin 80, right?